welcome to chapter 19. Here we're studying flow rates. So a flow rate is volume over time. In example 1, we're looking at an order of normal saline, 1000 mLs continuously for 24 hours via IV. We're going to find the pump setting in mLs per hour. So they're telling us it's 1000 mLs in 24 hours, which when we divide that out, we get 41 and 6 repeating. So I'm going to round that to 42 mLs per hour. So here we're looking at 120 mLs in 90 minutes. And again, there's a couple different ways to do these. Um, 120 mLs in 90 minutes, but we're calculating it in mLs per hour, so I have to change my minutes to hours. 60 minutes is the same as 1 hour. If you knew that 90 minutes is an hour and a half, you could have put 1.5 hours down here. You'd get the same thing. So here, I'm going to zip out my 0. We get 80 milliliters per hour. I'm going to set this example 3 up as a ratio problem. We're given lactated ringers, 167 mLs will go in per hour for 6 hours. So how many mLs will the patient receive in 6 hours? So I have 167, we don't know, over 6 hours. So I do my cross product, and I get x times 1 equals 1002 mLs. NIV has been infusing 30 milliliters for 8 hours. Again, I'm going to set this up the same way, 30 mLs per hour equals X mLs in 8 hours. I do my cross product, and I get X equals X times 1, 8 times 30. And I know my answer is going to be in mLs. In example 5, we have 5% D5 and W. That part doesn't matter for the computation of this problem. We're going to start with 60 mLs per hour, which is our rate. And now as a ratio, I have 300 mLs. And we want to know at this rate how long it'll take us. So I do my cross product, and I get 60x equals 300. Divide both sides by the coefficient of x. Therefore, X equals 5, and my units is hours. Example 6, again we have our normal saline, which we don't really care about right now for our computations. 500 milliliters at 125 milliliters per hour, and we're gonna infuse 500 mLs, but we don't know how long it'll take us. So we do our cross product. 125 times X equals 500 times, this is basically a 1 hour. Divide both sides by the coefficient of X. We know our units is going to be hours. So when I divide 500 by 125, I get X equals 4, and my units is hours. In example 7, 1/2 normal saline. I don't really care about that right now, but I do care about 1000 mLs at a rate of 50 mLs per hour. Right, this should be my X. 50X equals 1000. X equals 20 hours. So now if we start at noon, on Monday, we're going to add to that 20 hours. That gives us 3,200 hours, which isn't possible because we only have 24 hours in a day. So 3,200 minus 24 gives us 0,800 on Tuesday. So here I'm going to set up my 1000 mLs over 8 hours equals 125 mLs per hour. So I just reduce this to 125 mLs per hour. Now we're going to use this flow rate, 125 mLs per hour, and we're going to use 20 drops per minute. So I got to translate this into minutes. So we have 1 hour, 60 minutes times 20 drops per ml. Hours cancel, mLs cancel. We have drops per minute. And that's exactly what we want. So now we just do the multiplication and the division. So I have 20 times 125 divided by 60. And I'm going to round that to 42. Drops per minute. Here we have 850 mLs in 8 hours. Our drops per ml. Well, let's get this in minutes. So we have 1 hour, 60 minutes, and then we have 10 drops per ml. And we're calculating in drops per minute. So do we have drops per minute? We have drops per minute. And now we multiply and divide. Let's see, so I'm going to take 850, let me clear that out. 850 times 10 divided by 8 times 60. 17.7 which I'm going to round to 18 drops per minute. Here we're looking at D5 and half normal saline. Again, not pertinent to our problem, but it will be when you're a provider, need to know what solution you're grabbing. So here we're just looking at 21 drops per minute. We have 60 minutes in an hour, because we want mLs per hour, and our setup is 1 ml per 20 drops. My drops, my minutes are gone, ml per hour. 21 times 60, well, I could do this 1 and 3, so 3 times 21 gives me 63 mLs per hour. And example 11, I'm going to start with my 125 ml per hour times 60 microdrops per ml. Now you may be wondering, where did I get the 60 from? The 60, a microdrop setting is always 60 microdrops per ml. And then we have 1 hour is 60 minutes, because we want microdrops per minute. So we have microdrops per minute. So my 60s cancel, because there 60 goes into 61, 60 goes into 61, and I'm left with 125 microdrops per minute. And I will finish up on the next video.